Welcome, welcome to Indian Academy for All. Today we will discuss about difference between plan and map. Differences between plan and map, right? So, what is the basic objective of surveying? Why we are doing surveying? Is to prepare plans and maps. Is to prepare plans and maps, right? So, we are studying about what is plan and what is map, right? So here a plan is a geographical representation to some scale of the features on, near or below the surface of the earth as projected on a horizontal plane, right? So here the horizontal plane is represented by plane of drawing sheets on which plan is drawn to some scale. However, the surface of the earth is curved. It cannot be truly represented and plane without distortion. So in plane surveying, the area involved are small. The earth surface may be considered as plane, and plan is plan is considered by orthographic projection. A plan is drawn on relatively large scale. On relatively large scale. What is the meaning of that? Simple. See here, why we are doing surveying? Simple, is to prepare a plans and maps. Is to prepare a plan and sign map. So here, what is a plan? Simple. So here, that is a graphical representation. Graphical representation, right? So here we are preparing a plan. Here we are preparing a plan drawn to on a relatively large scale. Relatively large scale. For example, building plan. Building plan. So here we are drawn the building plan on a relatively large scale. On a relatively large scale, right? So here, if you want to take notes, please pause this video and take all these notes, all these points, right? See here, plan means, so features on the surface is there, right? So here that features of that surface we are transferring into a paper, right? So here in the plan we are drawn to a large scale. We are drawn to a large scale. That's it. And see, plan is a always two-dimensional one. Plan is always two-dimensional one, right? Clear? So here we are not consider the curvature of the earth in the plan. Yes or no? Right? Simply we are taking picture or plan of that particular feature on the surface, right? That may be building, that may be anything, right? Clear? So simple. In the plan we are drawn on a relatively large scale. That is the two-dimensional one. That is the two-dimensional one, right? Next, map. What is the next one? Map. So here map means if the scale of the graphical representation on a horizontal plane is small, right? Clear? The plan is called a map. The plan is called a map. See here, India map, right? So here India map, we are drawn to a some suitable scale. Yes or no? Right? Right? Clear? So here we are drawn this India map on a paper with some suitable scale, right? Clear? So here the scale we are using is small scale, right? Clear? India map, for example, right? Clear? Right. Next, thus graphical representation is called a plan if the scale is large, while it is called a map if the scale is small. See, if the scale is small, then that is called as a map. If the scale is large, that is called as a plan, right? Clear? Next, map we are preparing three-dimensional one. Three-dimensionally we can prepare, right? So here horizontal and vertical, right? Horizontal, what means like that? See here, L, B, h, right? So here h means vertical distances. So here vertical distances were we are shown on the paper or in the map by contour lines, right? Next, on plan generally only horizontal distances and directions or angles are shown on topographical map. However, the vertical distances elevation are represented by contour lines, right? That is the map, right? Clear, right? Next, yeah, look here, this is the plan. This is a plan, building plan, or features are there, right? Here building is there, right? Here garden is there, right? Clear. Next, here swimming pool is there, like that, right? So this here, this is the plan, right? Clear. Next, map. Look here, this is the map, right? Clear. This is the map, right? So here map scale, small scale, we are drawing on a small scale, right? Clear. Next, scale. Next topic is scale. Means, so here it is a basic requirement for the representation of plan or map on a scale used to represent a large distances on paper. See, for example, 1 kilometer is there on ground. We cannot show that 1 kilometer on paper, right? So here we are decreasing or increasing the actual length on the ground, with the help of scale only, right? So here the ratio by which the actual length of the object is reduced or increased in the drawing is known as the scale, right? Clear. See, 1 kilometer is there, right? So we are showing on the paper maybe with uh, 1 centimeter, right? Clear. So here we are reducing. See, actually 1 kilometer is there, but we are showing as a 1 centimeter, right? Clear. Right. See the example. If the 1 centimeter on a map represents a distance of 10 meters on the ground, then the scale is said to be 1 centimeter is equal 10 meters. Then 1 centimeter is equal 10 meters. So here 10 meter is the actual distance on the ground, 1 centimeter is on paper. So how we are reducing this? With the help of scale only, right? Look here, this is the scale, right? Clear. Different types of scales, maybe in feet, maybe miles, maybe kilometers, right? Clear. Right. Look here, topographic maps, right? 1 kilometer, 7,000 feet, 1 mile, like that, right? Clear. Next, representative fractions, RF. Next concept is RF. What is RF? Simple. The ratio of the distance on drawing to the corresponding actual length of the object on the ground is known as representative fraction. Simple. See here. See, actually the ground distance is 1 kilometer, for example, right? So we are taking that 1 kilometer as 1 centimeter in on the paper, So here 1 centimeter divided by 1 kilometer, then this is known as RF, representative fraction, right? Clear. RF, representative fraction. Okay now, right? Next, look here, RF. I will give one example here. 1 centimeter is equal 10 meters, for example, right? Here RF is equal to 1 centimeter by 10 meters, 1 centimeter by 10 centimeters, right? Look here, I will give example. RF, right? 1 centimeter divided by 10 meters, right? Clear. So 1 centimeter, 1 meter is equal to how many centimeters? 10 or 100, right? 100 centimeter, right? Here centimeter gets cancelled. 1 by 1000, 1 by 1000, or 1:1000. So this value is known as RF, 1 by 1000 or 1 is to 10, 1 is to 1000 is known as RF, right? Look here. For example, we have 1 centimeter is equal to 100 meters, right? So actual length is 100 meters, on the paper 1 centimeter, right? So here simple, 1 centimeter divided by 100 meters, right? Convert this meter into centimeter, 100 centimeter, yes or no? Right, so here 1 centimeter gets cancelled, then 1 is there, below we have 10,000, right? So here RF value is 1 is to 10,000 or 1 by 10,000, right? Look here, 1 kilometer, right? Simple. So convert that 1 kilometer into a centimeters, because here we have centimeters, right? Clear? Next, the type of RFs, different types, right? 1 centimeter. So here if we may be converted into the miles to the kilometers, kilometers to the centimeters, centimeters to the inches, right? How we want, we convert, right? Graphical representation of scale. So here how we are representing the scale graphically, right? Simple. Graphical representation of scale on maps has advantage that if the paper shrinks, the scale will also shrink accordingly, and the distance representative will not disturbed, right? So here graphical representation of scale is important. Why? Because see, while preparing a map or plan, we are drawing, we are taking graphical scale here, right? So if the paper may be shrink, if the paper may be shrink, so automatically this scale will also shrink, this scale will also shrink, right?